Good morning dear students, welcome back. So this is a video on model question paper. Already I have uploaded two videos on this model paper discussion. Both the videos are about module 1. So here is module 2. Module 2 is consisting of questions from modern physics and quantum mechanics. So I will discuss questions from modern physics and quantum mechanics. Here is the question number 3. Of course, this is the question paper pattern. So this is where this particular module I am going to discuss. This is module number 2, question number 3 and 4. Already I have discussed question number 1 and 2 in my previous two videos. And the pattern is like this. You will have three questions. Question number 3 A, B, C. Number 4 A, B, C. Obviously C is a numerical, and the marks distribution, as I told already in the introductory video, 6, 9, 5, 10, 5, 5, like that. So for numericals, maximum marks allotted is 5 only. Okay, now comes the first question, or question number 3. Derive an expression for de Broglie wavelength by analogy and hence discuss the significance of de Broglie waves. So you have to derive the expression for de Broglie wavelength, that is lambda is equal to h by p. So this is a direct simplification. You can start like this. According to Einstein's mass energy relation, E equals mc square. So you take this formula straight away, and if you want you can explain what is m, what is c, and even otherwise also it is understood. M stands for mass, c is the speed of light, E is energy. Next, according to Planck's quantum theory of radiation, E is equal to h nu. This is also well known equation. Now both are having same parameter on the left side, that is E and E. So therefore RHS must be same. So next step, from equation 1 and 2, mc square equals h nu, or you write mc square as mc, so transfer 1c this side. Halige RHS becomes h nu by c. Okay. Next, we know m into c, that is mass into speed of light, or mass into velocity, is nothing but momentum. Mass into velocity is momentum, so I write p, and c divided by nu is equal to lambda. This is a well known relation. Velocity, frequency and wavelength are connected through this equation. Velocity divided by frequency is equal to wavelength. So therefore this equation becomes, so in the place of mc I write p, and in place of h I write h only. Observe carefully dear students, I have nu divided by c here, but c by nu is a lambda. Therefore, nu by c must be 1 by lambda. So h into 1 by lambda can be written as h by lambda, or lambda is equal to h divided by p. So wavelength of the de Broglie matter wave is equal to the ratio of Planck's constant and momentum. So lambda is given by h by p. So this is the derivation of the expression for de Broglie wavelength by analogy. Analogy antandre with the help of these equations anta. Now let us talk about the significance of de Broglie waves. Well, I just give only two significances and most important significances. Matter wave is associated with matter wave is associated with a periodic variable called wave function. Dear students, when particles are moving, they are behaving like waves, and with each wave there exists a periodic variable called wave function. Wave function is a function of position and time. It is a property. It is a property of the matter wave. It keeps on changing with respect to x and t. So it is a function of x and t. So we call it as psi, that is f of xt, right? And this wave function gives you the probability of finding the particle at a given place x at a given interval of time t. So wave function is a probability measurement. Keep it in mind. Next, particles, position, momentum and other parameters can be better explained by matter waves associated with them. I already mentioned this in my superconductivity videos. Cooper pairs are explained by matter waves. So when it comes to subatomic domain, particles are not treated as particles. Particles, because they are moving, they behave like waves. And if you treat particles as waves, then easily you can understand their behaviors, their properties, their characteristics and their values, like what is the energy, what is the momentum, what is the kinetic energy, what is its position. All these things can be understood in terms of wave function or in terms of matter wave. Therefore matter wave is very much important to understand the particles behavior. So this is about the significance of de Broglie matter waves. Okay, now with this I move on to the next question. Explain the wave function and mathematical form. So wave function in a mathematical form. Explain the wave function along with its mathematical form and discuss the physical significance of wave function. In fact, this question is just continuation of the previous one. In the previous question, I was talking about the properties of matter waves, importance of wave function. So let me elaborate it further here. See, wave function. First of all, what is wave function? Wave function is mathematical function in quantum mechanics, which is determined by physical situation of the system, and it is represented by symbol psi. So ಒಂದು ಪಾರ್ಟಿಕಲ್ ಇನ ಫಿಸಿಕಲ್ ಸಿಚುವೇಶನ್ ಅನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ. ವಾಟ್ ಈಸ್ ದ ಪೊಸಿಷನ್ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್, ವೆದರ್ ಇಟ್ ಈಸ್ ಮೂವಿಂಗ್ ವಿತ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವೆಲಾಸಿಟಿ ಆರ್ ವೇರಿಯಬಲ್ ವೆಲಾಸಿಟಿ, ವೆದರ್ ಇಟ್ ಈಸ್ ಇನ್ ದ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಆರ್ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್, ಆರ್ ವಾಟ್ ಅಬೌಟ್ ಇಟ್ಸ್ ಮೊಮೆಂಟಮ್, what about its position, what about its other parameters like spin, etc., etc. All these things we can understand through wave function. So wave function represents the state of the particle, therefore it is also called as a state function, and this wave function is normally represented by this formula psi of xt. I told you, it is a function of position and time, is equal to a into e to the power of minus I omega t minus kx. Actually, wave function is imaginary. Wave function here it is negative. But I told you, wave function represents probability of finding the particle. So probability cannot be imaginary. Probability cannot be negative. I will come to that later on. So before that, let me talk one or two more points about the wave function. Well, here, look at the next property or next point. Wave function psi contain all possible information about the system. This is what I told about the particle. So many informations I want to extract from the wave function. What are all the informations I can extract? I can extract about its position, momentum, kinetic energy, total energy. Okay. All these informations I can extract with the help of wave function. That is why wave function is called state function. So hence it is also called a state function. Such wave functions are obtained by solving Schrodinger wave equation. Schrodinger wave equation is one of the basic equation for quantum mechanics. Like Newton's laws are for classical mechanics, Heisenberg uncertainty principle is for quantum mechanics. Like equations of motions are for classical mechanics, Schrodinger wave equation is for quantum mechanics. So like that. So in classical mechanics, we extract the details of the macro particles like marble, stone, or any massive bodies like sun, moon, or interstellar bodies like that. That is classical mechanics. Here I am going to extract the information about microscopic particles like protons, neutrons, or electrons, or atoms, or molecules, or ions, etc. Okay, so there we need essentially wave function and Schrodinger wave equation. Second one, once the wave function is known for a particular system, then physical observable quantities like energy, momentum, position, etc. can be determined. Andre wave function gottaitu antandre particle ge sambandhapattante energy, momentum, position, etc. ella kuda navu kandidibodu. We can determine the particle parameters like energy, momentum, position, etc. And wave function psi is a measure of probability of finding the particle at a given position at a given time, at a given position. Let us say you are in your college from morning 10 to 5. If I try to find your position in your house, so probability is 0 because you are in college. Suppose if I try to find your position in college after 5 o'clock, so probability is 0 because you are at home. So like that, probability keeps on changing from place to place, keeps on changing from time to time. So that is probability function, wave function. But probability cannot be 0, sorry, can be 0 but cannot be negative, cannot be imaginary. In order to overcome this, Max Born gave a beautiful suggestion, and that suggestion is here. Wave functions are usually complex. I told you, minus I is a complex number with both real and imaginary parts. If that is the case, then it will be very difficult to give the physical interpretation. Real part we can easily explain, but imaginary part, how do you explain? So it is not possible. Therefore, we have to overcome this problem. This problem will not arise if you take the square of absolute value of psi. Andre psi na complex conjugate inda multiply ಮಾಡಿ ಅದಕ್ಕೆ ನೀವು ಮಾಡ್ಯುಲಸ್ ಅನ್ನು ತಗೊಂಡ್ರೆ then it becomes modulus of psi square, and now this is called probability density. I tell you, dear students, this is something like this. Let me write it and explain. See, in case of waves, you all are familiar with waves. I write a wave pattern here. Okay, this is a wave, sinusoidal wave, right? And what actually this particular part is known as? We know it is amplitude. See, amplitude is either positive, see upper portion positive, lower portion is negative, amplitude is negative. But if I want to have only positive value, what I should do? I have to take the square of that. Suppose this is 3, then 3 square is 9. Okay, if this is minus 3 square is also 9. Okay, so when you go for square, amplitude, sorry, that negative parameter becomes positive. But now I cannot call this a square as amplitude. I should call it as intensity, also called as radiation density. This is what is known as radiation density. ಗೊತ್ತಾಯ್ತಲ್ವಾ? Normal waves ಅಲ್ಲಿ amplitude square we take it as intensity or radiation density. In case of matter wave, because psi is negative, psi is imaginary, I multiply this by its complex conjugate and then I take the modulus. Then it becomes modulus of psi square. Now it is always positive. Now it is always real. This is nothing but probability density. So this is about Max Born's interpretation. This is also known as Max Born explanation. Okay, this is about matter waves, wave function properties or physical significance of wave function. Physical significance of the wave function. Just I erase this. Okay, now let us move on to the next question. Okay. Calculate the energy of the first 3 states for an electron in one-dimensional potential well of width 0.1 nanometer. This is a direct question and the equation is here. En is equal to n square h square by 8 ma square. N is the integer. If you take n is equal to 1, this becomes ground state. If you take n is equal to 2, this becomes first excited state. Like that you can take any value for n. Starting from 1, n cannot take 0 in fact. N always starts from 1. Okay, n can be 1, n can be 2, n can be 3, n can be 4, etc. So n is equal to 1 corresponds to ground state, also called as 0 state. This is the first excited state, this is second excited state, third excited state, like that. So here is the equation. Substitute for n equals 1. So put n is equal to 1 because as per the question I have to calculate the first 3 states, that is n is equal to 1, n is equal to 2, n is equal to 3. When I substitute n is equal to 1 in the above equation, see n becomes 1, h is 6.62 into 10 power minus 34 whole square divided by 8 into mass is 9.1, that is mass of the electron, into 10 power minus 31. A is 0.1 into 10 power minus 9 whole square. So ishtunu substitute ಮಾಡಿ calculate ಮಾಡಿದ್ರೆ I get the answer here. Actually this is in joule. Normally we expect answer in electron volt. Final answer you have to express in electron volt. Therefore convert this to electron volt by dividing the whole answer by 1.6 into 10 power minus 19. So when I do so, I get the answer as 37.62 electron volt. So this is the ground state energy, that is n is equal to 1 level energy. Now I go for n is equal to 2. When I put n is equal to 2 in this equation, see this h square by 8 ma square remains as it is. In the place of n, I write 2 square. That becomes 4 times of this. 4 times of this andre 4 times of h square by 8 ma square. And already we know h square by 8 ma square is E naught. So therefore it is 4 times E naught. Dear students, directly you can write this as 4 times E naught. So you need not have to substitute for h, m, a once again. Just multiply E naught by 4. E naught already we know it is 37.62. So 4 into 37.62, that is equal to 150.48 electron volt. So this is the energy correspond to first excited level, or n is equal to 2 states. That doesn't mean that this is E2. Idu E1 ene idu. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಲ್ವಾ? Next I go for n is equal to 3. So when I go for n is equal to 3, I get it is overlapping, I erase this part. So when I go for n is equal to 3, it will be 9 times E naught. Okay, so 9 times E naught, because 3 square is 9 E naught, 9 into 37.62, that is 338.58 electron volt. So this is about the next level. See here, this question they can twist. They can ask you to calculate the energy of the first 3 excited states ಅಥವಾ first excited state and the second excited state. Like that also they can ask. First excited state means n is equal to 2. Second excited state means n is equal to 3. Okay, so you must know the meaning. N equals to 1 corresponds to ground state. N equals to 2 corresponds to first excited at the second level. So like that. So in the energy level diagram we have so many energy levels, right? So in the energy level diagram we have ground state. This is E naught. Afterwards comes first state, second state, third state, fourth one, fifth one, and so on. Okay, so last state will be nth state. It is nothing but n minus 1th excited state. ಆ ತರ ನೆನಪಿಟ್ಕೊಳ್ಳಿ ನೀವು. Okay, well with this I move on to the next question. Next question is 4a. Here I have explain eigenfunctions and eigenvalues and hence derive the eigenfunction of a particle inside infinite potential well of width a using the method of normalization. Dear student, this is a very lengthy question. First I read the question, I will explain eigenfunction and eigenvalues. Derivation part I will postpone it. This is most expected question. So eigenfunction andre ಏನು, eigenvalues andre ಏನು ಅಂತ ಹೇಳ್ಬಿಡ್ತೀನಿ. Wave function you already know. If the wave function is single valued, that means it should have only one value. If it is finite, that means it is not infinite. And first derivative is continuous. What do you mean by first derivative? I tell you. If you differentiate psi with respect to position delta x or with respect to time delta t, these are called first derivatives and they must be continuous. There should not be any discontinuity. Then we call that as eigenfunction. Actually eigen is a German word. In German language eigen corresponds to proper anta. The meaning of eigen is proper. So what is eigenfunction? If a wave function is having only one value, single value, means only one probability at a time. For example, I want to check you in your college. So I have only one value, 100% or 0 or 10%, something like that. Only one value. At a time I cannot find two values for you. ಈಗ ನೀವು ಕಾಲೇಜಲ್ಲಿ ಇದ್ದೀರಾ ಅಂದರೆ ಕಾಲೇಜಲ್ಲೇ ಇದ್ದೀರಾ ಅಂತ, ಮನೆಯಲ್ಲಿ ಇಲ್ಲ ಅಂತ. Suppose I get 100% probability in college as well as at home at same time, my measurements are wrong. ಇವಾಗ ಅಶೋಕ್ ಅಂತ ಸ್ಟೂಡೆಂಟ್, ಅವ್ನು ಕಾಲೇಜಲ್ಲೂ ಇದ್ದಾನೆ ಬೆಳಿಗ್ಗೆ 10 ಗಂಟೆಗೆ, ಮನೆಯಲ್ಲೂ ಇದ್ದಾನೆ ಬೆಳಿಗ್ಗೆ 10 ಗಂಟೆಗೆ ಅಂದರೆ ಅದು ರಿಡಿಕ್ಯುಲಸ್ ಅಲ್ವಾ? Nobody will accept. Either Ashok will be in the college or he will be at house at 10 o'clock. But Ashok will be in the college at morning 10 o'clock, at home evening 9 o'clock or evening 6 o'clock or night 10 o'clock ಆ ಥರ ಹೇಳ್ಬೋದು. But at a time he cannot be found at two places simultaneously. That means psi is single valued and it should be finite. Infinite probability there is no meaning. I can see Ashok infinite ಅಂತಂದ್ರೆ there is no meaning. I cannot see Ashok, okay. I can see Ashok 100 times, okay. I can see Ashok only 20 times out of 100 attempts, it is correct. I cannot say probability of finding Ashok is infinite. Okay, so that is the meaning. So if a wave function satisfy all these properties, then it is called eigenfunction. And these eigenfunctions are multiplied by some operators. There are various operators in quantum mechanics. The concept of operator is slightly higher for your level. You just take it for granted. We have integration as an operator, summation as an operator, differentiation as an operator. Athara, for energy calculation there is an operator, for momentum calculation there is an operator. So when I do that operation on the wave function, I get some answer. Okay, when wave function is multiplied by energy operator, I get some value. Momentum operator, I get some value. So one wave function anna, when I multiply by some operator, I get definite value, proper value, that is called eigenvalue. So eigenfunction is a proper function, eigenvalue is a proper value. Got it? So eigenvalue need not be energy, it can be momentum also, it can be anything. So it all depends upon which operator you are using, you are doing on this particular, okay, on this particular wave function. If eigenfunction is multiplied by energy operator, eigenvalue is energy eigenvalue. If eigenfunction is operated by momentum operator, eigenvalue is momentum value. E tara hogutte. Well, I just gave you the explanation of eigenfunction and eigenvalue. Then remaining part of this question I will continue in the next video. Till then, goodbye. Thank you for your patient hearing. Thank you for your constant support. I will meet you in the next video. Keep sharing my video with your friends. Keep liking my videos also. Thank you once again.